In this video, we're going to continue to discuss probability rules. In particular, we're going to focus on the addition rule. The addition rule is used in computing the probability of A or B. Or is the key word here. We have to know a few things about sets before we get introduced to the formulas. Two events are mutually exclusive if they cannot both occur. An example of this would be right now, where I live, it is both sunny and light outside, and it is dark outside. These events would be mutually exclusive. If events A and B are mutually exclusive, the probability that event A or event B will occur is just the sum of the individual probabilities. If events A and B are mutually exclusive, then in mathematical notation, P of A or B is equal to P of A plus P of B. Two events are not mutually exclusive if they can both occur. Here we add the probability for each event, but subtract the overlap A and B because it is counted twice. If events A and B are not mutually exclusive, then in mathematical notation, P of A or B is equal to P of A plus P of B minus P of A and B. Together, the formulas above are known as the addition rule. Here is an example to help us distinguish between mutually exclusive sets and sets that are not mutually exclusive, and how we develop the addition rule. The probability of A is equal to 6 out of 8, since there are 6 outcomes in A out of the total of 8 outcomes. The probability of B is 4 out of 8, since there are 4 outcomes out of the total of 8 outcomes. The probability of A and B is 2 out of 8, since there are 2 outcomes that live in the intersection of the sets A and B. The probability of A is 75%, the probability of B is 50%, and the probability of A and B is 25%. Now we might think that to find the probability of A or B, we would just add how many outcomes we have in A and how many outcomes we have in B divided by the total number of outcomes. Let's just try this. Well, we know P of A is 0.75, and we know P of B is 0.5. If we just add these two probabilities, then we end up getting 1.25. We know this is incorrect since probabilities always have to be between 0 and 1, and what we found is that this is more than 1. The reason that we end up getting an additional 0.25 is because when we count the outcomes in A, there are 6. When we count the outcomes in B, we've already counted the 2 that were also in A. So we're double counting those outcomes that are in the intersection of A and B. So we have to subtract off the probability of A and B. And so we get 1. This is a picture of two events that are mutually exclusive. We can see that in this picture, A and B do not overlap. So the probability of A and B is 0. If I want to find the probability of A or B, using the same formula that we derived in the last example, we get P of A plus P of B minus P of A and B. We know P of A is 0.25 and P of B is 0.75, and since there's no intersection, the probability of A and B is 0. We didn't really have to subtract 0. We just had to know that the events were mutually exclusive, and then we're just adding the probabilities of A and B together. Let's look at an example. The U.S. Census Bureau surveyed 100,000 households where 305,688 people lived. The Census Bureau wanted to get social and economic information about people living in the U.S. The two-way table below shows the number of people in the 4 regions of the U.S. who have no health insurance, and the number of people who have some type of health insurance. Are the events living in the South and living in the Midwest mutually exclusive? Two events are mutually exclusive if they have no common outcomes. Are there people who live in the South and live in the Midwest? According to this table, no. There's no intersection between the Midwest and the South. Here we have the South, and here we have the Midwest. You can see that there's no overlap between the green and the blue. Find the probability that a randomly selected person lives in the South or lives in the Midwest. This probability can be represented as P of South or Midwest. Since the events are mutually exclusive, we can just add the probability of South and add the probability of Midwest. Both of these probabilities are just marginal, so we compute them by looking in the totals in the margins and dividing by the grand total. The total who live in the South is 113,137, divided by the grand total, 305,688. The total who live in the Midwest is 66,006, divided by the total, again, which is 305,688. We get approximately 0.586. Are the events living in the South and having no health insurance mutually exclusive? Here we have the row living in the South, and here we have the column no health insurance. You can see that there are 21,639 people who live in the South and have no health insurance. So these events are not mutually exclusive. Find the probability that a randomly selected person lives in the South or has no health insurance. This probability can be represented as P of South or no health insurance. Since these events are not mutually exclusive, we're going to add the probabilities of the events A and B and subtract off the overlap, the probability of A and B. P of South and P of no health insurance are both marginal probabilities, so we're going to look in the margins to find the totals of each category and divide by the grand total. Lastly, we need to subtract off the probability of South and no health insurance. This is a joint probability, so we're going to look at the intersection of the categories. The joint probability of South and no health insurance is 21,639 out of the grand total 305,688. Since these have common denominators, we can add and subtract the numerators. You keep the denominator the same. When you add and subtract the numerators, you get 141,333, and the denominator remains the grand total 305,688. This, as a decimal, is 0.462. The last rule that we're going to look at is the complement rule. The complement of event A is not A. Because one of these must happen, their probabilities must add to 1. Because of this, we can find the probability of event A using the rule of complements, which in mathematical notation is the probability of the event A is equal to 1 minus the probability of the complement of the event A. Sometimes we write A to the power of C. This just means complement of A. The rule of complements is useful when event A is complicated, but the complement of A is easier. Pick one of the individuals in the insurance data above. Define event A to be A is equal to lives in the Northeast, Midwest, or South. I'm going to highlight these rows in the table below. We can see in the table that there's only one category remaining, and that is West. So the complement of A is West. Now we could compute the probability of A. That would be the probability of living in the Northeast, or the Midwest, or the South. But that would require adding 3 probabilities together. So this would be a good time to use the complement rule. Using the complement rule, we do 1 minus the probability of West. Probability of West is again just a marginal probability, so we look at the total who live in the West. That's 71,827 divided by the grand total. We get 0.765. The proportion of people who live in the Northeast, Midwest, or South is around 76.5%.